Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we are going to solve one important and conceptual limit involving the signum function, the absolute value function and the greatest integer function, right? So here we'll find the value of this limit when x tends to 0 minus. Here the negative sign shows that we are approaching towards x tends to 0 from the left of x is equal to 0, right? So here in fact we are finding out the left hand limit of this function when x tends to 0, right? So we are approaching from the left of x is equal to 0, right? Okay, so here the function is e raised to signum of x minus 2 divided by the absolute value of x minus 1 plus e raised to greatest integer of x plus 1, right? So here we'll apply the concept of signum function, the absolute value function and the greatest integer function to evaluate this limit, right? So let us start and let us take this limit as L, right? See here x is approaching towards 0 from the left of x is equal to 0, right? So it means we have to find the left hand limit of this function. So here what we will do, we'll take a point 0 minus h, that is we'll take x is equal to 0 minus h, and this 0 minus h lies towards the left of x is equal to 0, right, or in the neighborhood of x is equal to 0. So this point is 0 minus h, where h is a very small quantity, and when x tends to 0, h tends to 0, and h is a positive quantity and it lies between 0 and 1, right? And always remember that this quantity h is a very small quantity. So what we will do, we'll now express this limit in terms of h by taking x is equal to 0 minus h, right? So now we can write the limit L as limit h tends to 0, and we have e raised to signum of x minus 2. So we have signum of for x we can take 0 minus h. So here we have 0 minus h minus 2, and here we have mod of 0 minus h minus 1 plus e raised to greatest integer of 0 minus h plus 1, right? So now we can simplify it. So this is limit, this is h tends to 0, and we have e raised to signum of minus h minus 2, and here we have mod of minus h minus 1, and here we have e raised to greatest integer of 1 minus h, right? So now from this step what we will do, we'll apply the definition of signum function, right? And then we'll apply the definition of greatest integer function. So here we know that signum of say x is defined as plus 1 for all values of x which are greater than 0, and signum of x takes the value 0 whenever x is equal to 0, and signum of x takes the value minus 1 whenever x is less than 0, right? Okay, so here we have signum of minus h minus 2, right? So we know that h is a positive quantity, and this negative h minus 2, this quantity is always less than 0, right? So here inside this signum function, that is the quantity which is inside the brackets, that is minus h minus 2, this is less than 0. It means we have signum of some negative quantity, and from this definition we know that whenever x is less than 0 or x is negative, signum of x takes the value -1. So here we have -1, right? Okay, and see here we have e raised to greatest integer of 1 minus h. See, 1 minus h, 1 minus h quantity is slightly this is greater than 0 and slightly less than 1, right? Because h is a positive quantity, and when we subtract h from 1, then 1 minus h is greater than 0, but it is slightly less than 1. So 1 minus h lies between 0 and 1, right? And from the definition of greatest integer function, the greatest integer of 1 minus h must be equal to 0, right? Because 1 minus h lies between 0 and 1, right? Okay, so signum of minus h minus 2 is -1, and greatest integer of 1 minus h is 0, and here we have a mod of minus h minus 1, right? So here we can take minus h minus 1, so we can write it as minus of h plus 1, so we can take it as h plus 1, right, by the definition of absolute value function. So now this limit, it takes the form limit h tends to 0, and we have e raised to signum of minus h minus 2 is equal to -1. So here we have -1, and here we have mod of h plus 1, and here we have e raised to 0, right? Okay, so now when h tends to 0, here we'll take h is equal to 0. So now we have e raised to -1, and here we have mod of 0 plus 1, and here we have e raised to 0, which is equal to 1, right? Because e is the exponential number, and its power when it is 0, then it has the value 1, right? And here we have e raised to -1, and mod of 1 is 1, so we have 1 plus 1, and this is e raised to -1 over 2, that is equal to 1 over 2 times of e, right? So the value of this limit is equal to 1 over 2 times the exponential number, right? So viewers, this is how we can solve this limit.